Hello friends, today in this video we are going to learn how to read the schematic diagram as well as the board viewer. Now in the latest motherboards you can see there is a board viewer concept is there. That means there is no locations, names and location numbers are there. So everything you have to search by the board viewer. So in this video, I am going to teach you how to read the schematic diagram and how to use the board viewer simultaneously. And from that, you can able to trace all the signals, you can able to trace the problems, right? So let's start and learn schematic diagram and the board viewer.
So we now open this schematic diagram. The board number is 13283-1. And this is a Wistron board and it's basically used for the Dell laptops. So we now open the two things. One is this is schematic diagram in the PDF that we'll see how to use the schematic diagram and how the signal flows. And second, we open this board viewer. Okay, so this is a board viewer, and so we'll learn how to use this board viewer simultaneously. We read the schematic diagram, where the signal flows, where it is going, and how to test if it is a dead or if it is a no display, then how to test that all the signal. So first we'll go to the schematic. Okay, in the schematic this is a totally the 104 page diagram. Okay, so this second page is basically is a block diagram where this indicate that this is the CPU. Okay, this is a AMD processor used, and this processor information is given on the page number 3, 4, 5, 6, 7, 8, 9 till the 20, where the processor informations are given. And this is a flash ROM, it's called the BIOS. So page number 25. Then this is a memory. Okay, this is a RAM DDR3L, which is on page number 12. And if it is a graphic chips GPU graphics processor, then the information will be on 73, 74, 75, 76 and 77. So like that, so different things are given in this block diagram, so where it's connected. And this one is again one more important component, it's called the SIO. In a circuit diagram there is not mentioned SIO, there is normally mentioned a KBC or it's called ENE. Okay, the KBC means the keyboard controller. Okay, and this SIO's number is a 285. It's a make of Newton. There are so many SIOs like ENE, Newton, SMSE, IT. So in this motherboard, particular motherboard use Newton SIO, and the number is NPC 285. Okay, and this information is given in the page number 24, right? So we'll start, and this is these are the layer and these are the power inputs, and here in this side all the power inputs are given like this. We can go this side. Yeah, see the page number 44 is the charger information, like the battery inputs and adapter section. Then this page number 45 is a 3 volt and 5 volt section. The chip is TPS 511225. The page number is 45, 3 volt and 5 volt section. Page number 46 and 47 is used for CPU core voltage. The page number is 46, 47 ISL 95813 chips. And then page number 49 is basically used for the RAM supply. Then page number 48 for the system supply, that is a 1.05. Page number 36 for the DDIO supply, that is 1.05 and 3.3 S5 voltage. So these are the different pages are there for the different powers. So we'll start from the battery charging section. Okay, when we connect the adapter, how to flow, how it will glow, so how to test. So that information is here on the page number 44. So we'll go to the page number 44. Okay, so I'll type 44 here. So this is the page number 44. Okay, so this is the page number 44, and here this is my battery connector, and here is my adapter connector. So this is my adapter, this is my adapter. The adapter location is a DC in. Okay, in adapter, normally in Dell laptop, the adapter have a 3 pins. One is a positive, another is a negative, and third is the adapter ID, or it's called the PSID, where the adapter inform to the SIO that how much the power, how much the wattage the adapter can provide. So that information is there. This is only on the Dell and HP laptops. Okay, Lenovo and all laptop, they are not using this adapter ID signal or the PSID signal. If this pin is absent, then your adapter, this laptop will be turned on, but it won't charge the battery. So that you have to remember. Okay, so this is a PSID signal or the adapter ID signal. Then my voltage will be travel from here like this, from adapter 19 voltage, it will travel from here, and here is the first MOSFET. Okay, this is my first MOSFET. Okay, the MOSFET is this, the MOSFET is location is a PU4201. Okay, and this one is a N channel or P channel. This one is a P channel MOSFET. Okay, so you have to remember that is a P channel MOSFET, and the source is the input and drain is output. Okay, the 19 voltage, that DC voltage is given to the source, and it will come out from the drain and the gate control. Now to trigger, to turn on this MOSFET, this gate require a negative voltage. Okay, gate require the negative voltage, that is comes on the pin number 4. Okay, it comes on pin number 4. So this is that pin, and it will come the signal from the battery charging chips. Okay, so my voltage will be travel from here to here, and if I want to know where this is a MOSFET located, if I want to test, the MOSFET location is a PU4201. So if you want to search in BoardViewer, then what I have to do, I have to open the BoardViewer, I have to type this PU4201. So we'll go to the BoardViewer and we'll see. So this is my BoardViewer. So this side is the component side. So all the components are there. Okay, all the components are in this side. Okay, and this side is a signal side, all the voltages and all the signals. Okay, in BoardViewer, these are the signal side, and this for the component side. All the component like resistor, capacitor, MOSFET, chips, everything is there, and this side for the all the signal side. So this is the top, this is the bottom. You can use your keyboard also to flip the motherboard. You can flip the motherboard like this using a keyboard spacebar, and you can zoom the motherboard by using the scroll button like this. So here is my SIO. This one is my SIO. So if I click here, then all the pin information are given on this side. Okay, it's very easy to test. When I click that particular chip, that is KBC24, that SIO, all the pin information, that SIO have 128 legs, and all 128 legs information is given. Like we can zoom it also, we can click on a particular pin also, and that information is there. Like this signal is pin number 10 is a all system power good. Now what we have to do is, we have to find this MOSFET, where that MOSFET is located. The MOSFET number is PU4201. Okay, so we have to come here and type PU4201, right? Then we have to search like this. Then it will show this corner. Okay, this corner, this one is my PU4201, that particular MOSFET. So we are using here to BoardViewer to find the component where their location is. Understood? So here is this MOSFET. Now this MOSFETs are pinouts are given here. So this is MOSFET pin number 1, then 2, then 3, then 4, then these are the pins. So pin number 1, 2, 3 is a what? Is a source, right? Pin number 1, 2, 3 is a source, and these are the point. Means when I connect to that particular pin, then it will be the highlight where they are connected. You getting my point? You getting my point? When I connect, suppose if I connect pin number 6, then these all the pins will be highlighted. When these pins are highlighted, then you have to come to know that they are connected with each other. They connect each other. So you can test voltage either here or here or here or here or here, any one of the point. So the all points are the same. Okay. So it's very easy to understand. From BoardViewer you can come to know that which points are connected to where. Okay. So it's very easy. So now what we have to do is we have to check the 19 volt here at source. Then we have to check pin number 5, 6, 7, 8 at the drain. Like here, you have to check the voltage here, right? Or you can check here. The 19 volt should come here. If the 19 volt will not come there, then either that MOSFET is a faulty or it's not getting the triggering voltage to turn on that MOSFET, because this particular MOSFET is a P-channel MOSFET, right? So you have to check that. The next is, once this voltage is come out from here, this is called the, see, another thing you have to remember the name. The most of the people forgot all this name. See, this name is called the plus DC in, that is the input DC in, and this name is called a AD plus. Means the AD plus is connected to the another AD plus. Okay. Now see, in this page we are on particular page number 42 now, and these are the output, that's a drain. Now where this output will go? For that, what we have to do is we have to go here, find, and we have to type AD plus, right? And then you have to search. Then the AD plus will, that particular point will show you where they are connected and which page they are going. So we'll click on the next. See here, AD plus. Okay, right? So this is the input, two inputs, AD plus and AD plus, right? So these both pins are connected. Okay, both pins are connected. Now the next thing is this voltage will pass to PU4402 and then it will go to the PR4402, PU4402, this MOSFET. Okay, this MOSFET again is a P-channel MOSFET. Okay, so this is a location. PU4402 is what? PU4402 is a location number, and this one is the MOSFET number. Remember these two things are very different. This is called the location number and this is called the MOSFET number. This MOSFET number is a mention on its backside, on that particular MOSFET, on its this thing. Okay, so remember that, and symbol indicate whether this is a P channel MOSFET or the N channel MOSFET. So you have to memorize all the symbols. This is very important. Okay, and here the input is a drain and output is a source. Okay, so you have to check drain voltage and the source voltage. Here you should get a 19 volt, output also you should get a 19 volt, and the control by whom? The control by this particular chips, this chips PU4404. Okay, PU4404. The PU4404, how it will work? The PU4404 will get how much voltage? See, the DC plus and DC plus both are connected to each other, that is single track. Now this 19 volt, the same voltage will be travel from here to here to here to here to here. That is a DC in pin at pin number 20. So you should get how much voltage there? 19 voltage at pin number 20. Then there is a one more pin which is also very important, that is called the AC detect. AC detect means the adapter current detect. This is the AC detect means what? The adapter current detect. You should get here a 3 volt at pin number 6. Here if 3 volt is coming, then that means the adapter is detected, adapter is present. If the voltage is 0, that means the adapter voltage is absent. Okay, so how this 3 volt will come here? By a divider circuit. This 2 resistor PR4407 and PR4431. So if you find where these resistors are located, means suppose if the 3 volt is not come here, if it is a 0 volt here, if you are connected the adapter, then how you will find the location of the resistor? The same thing, what you have to do, you have to go to the board viewer and type the location PR4407 like this. PR4407, right? Search here. Can you see? Can you see this one? PR44. This is my chip PU4404 and this is a PR4407. So how much voltage will be there? At its one leg you will get a 19 volt and another leg the voltage will be a 3 volt. And what is the value of this resistor? What is the value of this resistor? The resistor value is 309 kilo ohms. See mentioned over here. So you can use the multimeter and check the value of this resistor. The resistor value is 309 kilo ohms. Okay, and this resistor value is 47 kilo ohm. So according to the Ohm's law, the voltage will drop here, that is somewhere around 3 volt, somewhere around 2.7, 2.8, somewhere around 3 volt. That will be drop here. So you have to check that. And if the voltage is 0 here, that means this resistor may be open. So you have to check this resistor, go to the board viewer, check the value of remove the resistor, check the value, and if the resistor is not showing 309 kilo ohms, then you have to replace this particular resistor, and this resistor is point to this chips. So when I click here, see that this point is highlight, so that means that this point is going to pin number 6. Pin number 6 means here, see, right? Understood? So this way you have to trace all the component, where they are located, how they are connected to each other. The next thing is, the next our important point is, that is a current sensing resistor. This is a very important component. This is our current sensing resistor. The location is a PR4409, and how much voltage will be here? Same, something around 19 volts. So we should get here 4402. How much voltage? 19 volts. So we have to go to the board viewer and type 4402. PR4402. See this one, this corner. Okay, this corner. So open a board, check the direction, check the location, zoom the board viewer by using a mouse like this, check the voltage here. It will show a 19 voltage, that is called the DC bat out, DC or battery. Here the voltage, this point, If the adapter is connected, the voltage will be 19, and if the battery is there, then the voltage will be the battery voltage. Okay, so you have to remember that from what is our power source. If it is a voltage coming from this side, that means the voltage coming from the adapter side, and if the voltage coming from this side, that means the voltage coming from the battery side. If this voltage coming from here, then the voltage will be 19 volt, and if the voltage coming from here, then the voltage something around 11 volt. So both voltage are different. So that is why here it's called a DC battery out. DC and battery out. Okay, so this is our system voltage. Basically it's called a system voltage, and it's going to the entire motherboard. It's going to the entire motherboard. So this is basically it's called a junction, right? So you have to check the voltage over here, right? So once we complete this task, then we have to go to the next section, that is our 3 volt and 5 volt section. So this is our 3 volt and 5 volt section. So how will come to know that? We can come to know from the index page, or we can come to know from this side also. See this corner, in every diagram there is a corner, that right side corner. So there the mention the index or the index number or the description about the page. So here it's a mention the Wistron Corporation is a manufacturer of this motherboard. The model number is SHRI AMD. This is a AMD processor Bima, and what is the description of this page is a 3 volt 5 volt section, and the chip is used by RT8230B. Okay, so this is a description of the page. So okay, so this is a page now, 3 volt and 5 volt section. At the center point, here is our 3 volt and 5 volt chips. There are 2 MOSFET on the left and right side, then the coils are there left and right side, and the capacitor. Okay, so if we zoom these chips, then we can come to know that the location of the chip is a PU4501, and the chip number is RT8230B. So these are the chip number and these are the location number. So we'll go to the board viewer and we'll see where the chips located. PU4501. PU4501. Right, so this one is our chips. See, you can zoom like this. PU4501. All the pinouts are on this side, description is there on this side, and this is a chip, and this is the pin number 1, connection is here, pin number 2 connected here, pin number 3, pin number 4 connected to this 2 resistor and capacitor, pin number 6, 5, like that. Okay, so the thing is, first we have to check the input. The input pin is pin number 11. Can you see here that my DC bat out voltage will be come to this chips at pin number 11. You have to check pin number 11, that is a 19 volt, and then we have to check the next voltage, that is called 2 linear output, is called the LDO03 and LDO05, linear digital output, 5 volt linear digital output, 3 volt. It's called a VRG3 and VRG5. These both are the linear output. You can see our another video, there is everything is mentioned in very animated way. So here you have to check the voltage. If the voltage is not coming here, then you have to check this point, pin number 12. This is called the enable LDO. LDO means the enable LDO. There are 2 enable signal, one for the linearly enable and another for the buck enable. So here you should get a 3 volt. Okay, now that DC bat 18 volt directly given to this here, pin number 12, that means above 3 volt is the enable signal. Okay, so once this pin number 12 voltage is coming, 11 voltage will come, then 3 volt will come out. Okay, so we'll go to the board viewer and we'll see V in pin V pin is what? 11 here. So this is my input. Here I have to check 19 voltage. Either I can check here, I can check here, or here, or here, whichever is convenient to me. Okay. The next is I have to check LDO03. LDO03, where it is? Pin number 15. Pin number 15. This is my LDO03. Here I should get a 3 volt, and this 3 volt is going to the SI. This 3 volt is going to the SI. You have to check like that. And then the LDO05. LDO05 like that. So in this way we have to check this chips, different voltages, enables and output, and once this voltage is coming, then the next will go to the SIO, and we'll see how this power on take place. So we'll go to the schematic diagram. So we'll go to the last page. There is a, you can see normally in Westron motherboard or in Dell motherboard, you will get ladders. You will see ladders. The ladders like this, it's called the power sequence. It's called the power sequence, means the how power flows. So suppose if you have a laptop and this laptop is dead, then you have to follow the steps from top to bottom. From top to bottom like that. So first you have to check what? First you have to check RTC VCC, that is a 3 volt, that is your CMOS battery. Then RTC X5 voltage, then the DC bat, that 19 voltage, then 3.3 aux voltage, that is a linear voltage, the LDO03, and then from SIO you will get this S5 enable signal, S5 enable signal, and that voltage will come out from SIO, that is a 3 volt. How much it will come? A 3 volt. But before that, SIO have some criteria. And what are those criteria? Number 1, he should get a power, he should get the EC reset, lead sensor, and thermal trip. So we'll see where those signals are. We'll go to the SIO page. Okay, so this one is my SIO. Okay, so this is my SIO, and what is the number? NPC 285. Okay, so I have to check what? I have to check the VCC voltage. This is my 3D3 means 3.3 auxiliary KBC voltage, that is a VCC voltage. You will get here a 3 volt at this pin. You can check 3 volt any of this pin. It's not necessary that you have to check any particular pin. You can check, you can select any pin, and if voltage is come there on one pin, that means it will come every pin. Okay, so first you have to check that. Then the next important pin is called the EC reset, ECRTC. So we'll find where it is. Yes, this is a ECRTC, EC embedded controller reset. This SIO need a reset signal. So here you should get a 3 volt, and this is a RC circuit delay, generator delay. So here you will get a 3 volt. Okay, so you have to check your 3 volt. Then you have to check what? The lead sensor, lead switch or lead sensor, and thermal trips, all the signal you have to check. If it is there, you have to find where are those signal, and once all the signal 3 volt will come, then next thing you have to check that which signal? SLP. Which signal it is that? SLP. This one signal. It will come out. This indicate the output signal and this indicate the input signal. This indicate the chip signal. This indicate the chip signal. This indicate the pin number, and this indicate the page number, where on which page it is going and whether it is input or output. And this particular indicate that signal name. Okay, so this SHRI enable signal will come out and it will enable a 3 volt and 5 volt section. It will enable a 3 volt and 5 volt section. If this SHRI enable is not come out, then the SIO is faulty. Okay, and if this signal is coming, then step by step you have to check RSM RST, then power button and PM power button, and then SLP4, SLP5, which I mentioned in another video. Okay, so friends, in this way you have to check this circuit diagrams and board view to test the signal. And I give you just brief information about how to read the schematic diagram in a battery charging section and 3 volt and 5 volt section and the SIO section.
So friend, in this way I explain you how to read the schematic diagram and the board viewer. Friends, simultaneously you can use our books. These are the 2 books. One is for the Windows laptops. In these books we give very easily method to repair the laptops. Like we give the power sequence, we give the signal test point, like a dead motherboard, no display problems, and from last 2 years we sold more than 2,000 copies of this book entire the world. So this is a hot selling item. Those who are in this field, in repair field, this is a very useful guide to repair the laptop from 1st generation to 10 generations. So you can available these books for the Windows laptop. Simultaneously we have the another books for the Apple laptops. So friends, this book for the Apple laptops. So in this book we explain the concept of MacBook, Mac Air and Mac Retina and Touch Bar laptops. Type-C power sequence, how to repair dead laptops, how to repair no display, deep display, everything is given in the flow charts. Very simple way. You can use these 2 books and you can become a good repair engineer and start your good careers. Everything is given very simple and animated and colorful way. To available these books and the videos or for any other inquiries, you can contact our below numbers and available all these stuffs. Okay, plus that we have online and offline classes also. We are located at Mumbai and we have online classes also. The videos we provide very scientific and very accurate way, so you can available that class also. So thank you very much for watching this video. Have a nice day.